Okay. So the reason this is basically an introductory class to ROS2, or what ROS is basically, and why should you learn ROS? And like, see, you guys did implement that Python thing, What Mustafa did was he created a GUI to control the arm. Correct? Am I right, guys? Yes or no? Or one thumbs up would be good. Okay. Nice. So, but when I'm creating a robot, someone else. When I'm creating a robot, it's not my job to sit and create the software stack, right? I don't have it. I want to work on the hardware part. I want to make my robot move in a particular manner. I have some idea. I have some algorithm, and I want to work on that. So, but then why should I spend time doing other stuff? For example, if we are going for that URC competition, right? And one of the tasks is autonomous navigation. So when we are talking about this autonomous navigation, the task given is like, I have to go. There will be a QR code. I have to go near the QR code autonomously. That I've just simplified it very much. Okay. Now to go to that camera autonomously, my wheels have to be controlled by a program, and the wheels uh, what speed the wheels must be going should be also decided by the program, and how my what is the path basically should also be decided by a program. So there are one path planning, one what is the speed I'm going and all that stuff, and one, and if I like, there is something known as slam, okay, which is like how the robot gets to know where it is. That is also there, so that part is also a program. What ROS essentially does is that it gives you a platform so that all these programs can talk to each other. That's the whole idea of ROS. And why was ROS created? It comes back to the first thing I said when we started the meet. Like, I don't want to create all this extra GUI stuff. Like, I want to directly work on algorithms. I want to directly work on the hardware part. So this problem is known as reinventing the wheel. Like, popularly, that is what they say. I'll just share my screen. Enter screen. One second. Enter screen box. Hello. Hello. My screen visible? Yeah. Okay. So see, this is okay. Before going to that, I want to, since you're talking about history of ROS. So see, first of all, ROS was started as a personal project of two guys from Stanford University. If you want, I'll send this article. You can read through it. I just skim through it once so that you'll know what was the idea of, or why was ROS created and why you should use it. So this was a personal project of two guys named Keenan Weirobeck and Eric Berger. Okay, and these guys are from Stanford University. And the problem which we described is basically reinventing the wheel situation. Which, so every time I have to create, for example, an autonomous robot, I have to start everything from scratch, from building my navigation algorithm, from sending the whatever velocity to the motors, everything I have to start from scratch, and I don't get enough time to do new research. And this is the same, not the same picture, no, actually the same picture Eric and Keenan used when they were pitching this idea of software which will take care of the basic framework, which will do all this work for the person who wants to work on the robot. And so what happened was they started this as a personal project, and then a company named I don't know, I forgot the company name. Right? And a company named, I think it starts from W. I forgot the name. Okay, company start then they started building personal robots. Okay, these same guys, they started to build personal robots, and once they started to build personal robots, uh, this they started focusing more on this ROS, and once they started to focus on ROS, the it took up very fast, and I have an image like how fast the ROS repositories and the packages grew. Like this was when they were working under that company, and how people started contributing to a single framework which can be shared by everyone. And that's the beauty of open sources also, right? So they started this. Look at the tangent, or look at the curve, how it's like straight up, uh, what, e, that's the thing. And once the number of packages and all started increasing, sadly what happened was the company suddenly announced in 2013 that we are going to dissolve. And everybody was wondering, and a lot of people in fact started using ROS like properly in their projects and all that. And ROS made deals with some companies and all to make sure smooth transition, not smooth transition, smooth working of the operating system, not of ROS itself. Like one example is Gazebo. Now, what is Gazebo? Gazebo is a 3D simulator. Okay, you can simulate any kind of world you want in Gazebo. So there are other simulators as well, but a lot of people, just because they're using ROS, and Gazebo is already very easily compatible with ROS, they didn't use the competitors or the other alternative which are available in the market. So when the company all of a sudden announced, bro, we are going to stop, we are going to dissolve. This happened in 2013. Yeah, like we are going to dissolve, and everyone was in shock. And that was when Open Robotics Society was formed to continue the work of Ross. The company name is Willow Garage. Okay, Willow Garage, that's the name. Okay, so that's what happens. And then this open source Robotics Foundation was started just to continue ROS and release newer distributions. Once once this came under Open Source Robotics Foundation, things started to pick up even much more easily. A lot of people started putting their drivers, putting all sorts of stuff, packages, or already created ones on ROS, and a lot of companies, normal hobbyists like us, and everybody, student college, especially colleges, started using ROS. And now they have released this is kind of the story of ROS. Now, why you should use, I told you, the reason is pretty simple: eradicate the problem of reinventing the wheel. I don't want to create stuff which is already available, and I want to work on new stuff. Okay. So this is exactly what happens in ROS. Okay. Now I gave you the example of path planning, localization. Localization is how the robot gets to know where it is. Navigation is how it moves. And now if I want to see all this environment, right, I need LiDAR, I need camera, I need wheel encoder. Now, not every wheel encoder or not every camera can be easily combined with a microcontroller. It needs its own libraries and all that stuff, and drivers, especially drivers libraries. So, what ROS essentially gives us is, it gives us a base so that you can use any popular camera or LiDAR or wheel encoder or any object, and it ensures smooth transition and usage of that product or component. And another huge tool when it comes to ROS is that there is RViz. Okay, so RViz, you can basically visualize whatever you are trying to say, whatever is happening. For example, you are using LiDAR and you want to see what the LiDAR is scanning. So you can use RViz to do that. Control, obviously, I told you that is. And the advantage of ROS2 is that in ROS1, there was it was like there was one main guy who will ensure communication between all these six little guys, we can call them. But in ROS2, they communicate directly with each other. That is one thing. We'll go technically and all in the next class, but the main points I want to tell this huh. Now this, okay. Now I'm going to starting to go into the documentation and other stuff, the history and why you want to use ROS. I've kind of covered. Now Vedram, do you want to add anything?
Yeah, yeah. So one thing you might be thinking is ROS an operating system, right? I mean, the word operating system is there in ROS, right? But we made you install Linux. We didn't make you install some other operating system called ROS or something. So, where exactly does this whole operating system thing comes into picture? Okay. So, when you're building a robot, you will have multiple high-level algorithms. You will have algorithms that deal with how you want the robot to move in a very complicated environment, okay, or figuring out what environment it's in with the details it's given. Those are extremely high level algorithms that are assuming that you're giving it a lot of data to even work. But the thing is that where is all this data coming from? This data is coming from kutti sensors that you've put throughout the robot. You would have put one wheel encoder. So what is a wheel encoder? It's basically a sensor that calculates how much a wheel has rotated. Okay, it's extremely important if you want to find out how much your robot has moved. If your robot has moved 1 meter, your wheel encoder will tell you, hey, your wheel has rotated these many degrees. Based on it, you can calculate how much the robot has moved. Okay, or you have IMU, which will tell you how much it is accelerating at a certain moment. So all these are low-level hardware stuff, right? As Lingesh told, all these complex algorithms will tell that the robot should move at a velocity. Who is going to execute that velocity? It's the motors on the robot and the motor drivers of the robot, which is controlled by a microcontroller like an Arduino, right? So ROS is basically like that overall thing, okay, between all these high-level algorithms and all the low-level stuff of controlling and getting data from the sensors. It is that all-in-one package that did not exist before. Okay, and it's extremely important to understand why you want to learn ROS. Okay, what is the use of all this? Because when you start out with ROS, no, you will be like you won't be able to add up the pieces. You'll be like, hey, what is all this? Okay, but like this is the whole point of it. It's like if I have a robot in real life. Okay, it's like assume like a four-wheel robot. I move it 10 meters in real life. In RVs, like as Lingesh told, that robotics visualization thing, it should also move 10 meters in RVs also. Okay. Then you can work everything out on your computer itself. You don't have to sit and do real life calculations or fetch the data from yourself. And also, as Lingesh said, it provides a place to compile all your drivers in one place. Before ROS existed, or if you want to build a robot without ROS, it's like, okay, now you have one program that takes the LiDAR data. Now you have a program that takes the wheel encoder data. Now you have a program that takes the IMU data. How are you going to combine all this together and make it work smoothly with each other? You don't need to sit and write software to, bring in all the data points together or to visualize it. You don't need to do any of that anymore. All you need to focus on is get data and put it in the right place, okay, so that your algorithms will use it. One more advantage is that you don't need to reinvent the wheel, right? Not just the software stack, even these algorithms have been, because ROS has been there since 2005, 2006. It's been some 15, it's almost like 20 years old now. People have already written all the common robotic algorithms in ROS, and it's extremely easily accessible as ready-made code. So once you figure out your low-level hardware stuff about how ROS interacts with your hardware and all, implementing the high-level algorithm is as good as just downloading a GitHub repository and running it after changing one or two parameters specific to your robot. ROS makes life easier in the long run, but when you're starting out, it can get extremely frustrating. But you have to push through it because it's extremely worth it in the end. So yeah, I guess that's about what I wanted
Yeah.
to add.
Like I want to add on to what Vedram was telling. Like, yeah, it's not very difficult. The learning curve is steep. Okay. And at the beginning, there will be some time where you will feel disheartened. It will be some random error which will only happen to your system because you are using this actually happened to me. Okay, I was using my Geo hotspot to install some packages from
To
ROS.
install
Okay, I
ROS you
want
mean?
to install. Okay, yeah, to
Okay.
install ROS itself. Okay, so what happened was, I am sitting and struggling. I am looking at the documentation from the ROS website. I am putting all the commands properly. I am putting it 100 times, but no matter what, it's throwing the same error at the end. I'm like, bro, I want to give up. And then I will you. What's the first thing you do when you get an error is you take it, copy the error, put it in Google, see if someone else has also got the same error. Now I check, nobody else has got the same error. I got fed up. I tried reinstalling some twice, thrice. Then the god of all platforms, Reddit, I opened and I put the same error, okay. And in some random topic which doesn't even have any relevance to ROS installation, it relevance to ROS, but not in the installation part. A guy has commented that he faced the same problem, and it happened only because Geo was the ISP, which is Internet Service Provider, and they've blocked the website, not the IP of the of
ROS
what is that?
servers.
Open of what?
The ROS server.
Yeah, of the ROS server. So then what you do is take the then what I did is take their server, add it to my host, and there was one file which we had to edit, and then once it's done, then the installation went smoothly. The reason I told the story was I sat for 1.5 hours trying to figure out the error, and the solution was just 5 minutes, but finding that solution is a process. And you guys will go through the same thing when you guys are installing. Something will go wrong, and it will, and you will feel like, why is it only happening to me? And that is exactly why I initially I wanted to show you the installation as well. Like I wanted to do it side by side, but then I know for sure there will be errors, and it won't be the same error also for everyone. So it will take some time. So what we are going to do is we'll send you a documentation to install ROS. I hope you guys are familiar with terminologies like terminal, running a command, etc., etc. Like whatever and also how to copy paste the commands. It's not just Control C, Control V. You have to use Shift as well. Control Shift C is copy, Control Shift V is paste. If you guys are getting to know this thingy now, it's you should definitely watch that 40-minute video because he has done a very good job explaining all this. Okay, now the main thing I want to like introduce to the Bible of ROS, which is like the documentation. I will tell you the what and all. I'll show you some stuff, and in another 5-10 minutes we'll back up. Okay, sharing my screen. Entire screen. Okay, visible. Yep. Okay, so this is the official documentation of ROS2. ROS1 looks different. If you want, you can go check it out. Not an issue. But this is ROS2, Kaveh, main website. It used to be known as ROS Wiki. Now it's docs.ros.org. Okay, now see there are so how ROS works is that there is something known as distribution. So every year they release a new version of ROS. It's not exactly new version. They call it new distro. So what happens is that I think from the if you see it will start A B C. The first version was A B C D E F G H. The version which we will be using is Humble Hawksbill. The reason is because it is a LTS version, which means there is a long-term support for it, and all your packages will be updated updated, and service will be provided by ROS. That is exactly why we'll be using Hawksbill, and this is your Bible basically. This from I think this concept of long-term service in ROS2 started from this guy Foxy Fitzroy, correct. Only they started from that. Before, other than the LTS version, there is short-term version which the end of life. See, this is EOL. Okay, end of life date is just 1 year. They'll support for 1 year, and the advantage of using these short-term version is that it will have a lot of new features, new tools which you can experiment with, and frankly, even they are experimenting with. And that is the reason people if you want to use short term people, I mean we don't suggest it to beginners start off with LTS version, and the version which we'll be using is Humble Hawksbill. Okay, Now, every how they have planned this is every new version of Ubuntu. Like you guys downloaded Ubuntu 22, right? For every new version of Ubuntu, there is a new version of ROS. This particular version is for, see, tier 1 platform is for Ubuntu 22. This is exactly the reason why we told download Ubuntu 22 only. It is also supported for 20, but it is, as you can see, it's a tier 3 platform and they don't suggest it as well. This is what this is the version you will be using. And now that that is done, end of life, it's till 5 years, so there's nothing to worry about it. Installation, I'll come. You have to see, if you guys want to start off with installation by yourself, well and good, amazing. But there are what there will, I don't think so. Wait, installation part, I'll go. Installation is it, my bad. Okay, installation. So what happens is which one you should choose and all that. Next, you choose Debian packages because Ubuntu is Debian only. So this is the process. You start from this page if you want to start off by yourself. It is recommended, but if you feel it a little haunting, or if you feel it haunting, just we'll send you a guide. Follow it step by step, and you should be fine. Hopefully, if you guys have any errors, don't send it to me personally. Put it in the group so that if when you solve it, or if someone else has already got the same error, you can help each other out. And okay, this is and a demonstration video. I think a demonstration video, we'll send it a recording with the file we'll send off. Okay, I think that will be better for you. The exact steps you need to follow, and you should be fine. If you have any errors, first step, Google it. Second step, put it in the WhatsApp group. And if someone has got the same error, you can help each other out. This is pretty much the thing. And see, even what we will be following, we'll be following these tutorials itself. Where is tutorial? Finally, tutorials, we'll be following these only, but maybe not in the same order. We'll be following our own custom order, so that to our goal is like what we want to create a nav stack at the end. So towards that we will be going. All the extra stuff you can learn it on your own time. So I think, yeah, that is pretty much it, to be honest. And like, I wanted to show you guys how this visualization works and all that. 1 second. So this is the RVS window. This is ROS1, okay, but still it's fine. We can use it. See, now it's closed. Uh, this is my RVS window. This is how it will open for you guys also. See, the advantage is that, see, now the GUI is already there. I don't have to sit and create the GUI. And you can also do a lot of other stuff as well. See, for example, LiDAR, no, not LiDAR, baseline, add robot. You guys have seen HIL, no? Can someone unmute and answer in the workshop?
Yeah.
Yeah, see, now you can visualize HIL on the RVS platform itself. Now, if I want to, now we have in the actual HIL, if I want to get laser data, I have to do a lot of, again, I have to find what is their driver, ROS particular driver for my uh, LiDAR, and then have to integrate it and all that stuff. But the advantage of using this RVS is for visualization. If you want to use Gazebo, I'll show you what is Gazebo is also. So this is how you basically visualize. If you want to add anything, see, for example, you create a map and you want to see what map you've created. There is something known as map topic. And when you click, now there is no map obviously, but if there is a map, it will show up here. Likewise, any thing you want, can be any kind of data, camera, depth cloud, some things which we might use is probably camera or LiDAR, laser scan. Laser scan, so 90% we might use in our stuff also. Point cloud, odometry. These are the things that we will be using, and what these are, you will get to know slowly. There's nothing to worry about this as of now. So this is one thing which I wanted to show. I'll close this. And another thing is gazebo. Hopefully it will work. English, launch. Okay. Gazebo.
When did you do this package, bro?
Bro, this was some long ago. I think I know. Once it started opening like some devil, no, haunted. After that, he figured out how to get it together.
Okay, send it to me. Send this package to me later.
Please. Okay, see, this is your gazebo window. This is how the gazebo window will look when you guys will be working also. And the main point of gazebo window is I don't want to sit and do everything in practical, right? So, for example, for the URC challenge, I want to create a world. You can actually, I don't think so. You can add it here. Okay. You can change every parameter also, the physics of the how the wind will be blowing and all that stuff. But more importantly, if I want to create a world, a custom world, for example, URC only, you think University Robo Challenge, I can create a space where there will be QR code already in the world, and I can simulate how the robot might work. And using that, I can make changes to my actual robot. That's the whole point of Gazebo. And it is a 3D simulator. You can change all the physical parameters and stuff. These are the two main things which you guys will be using, Gazebo and Arvis. If we are now, if we have enough time, we can also create a small world and launch our own robot. We'll see how things goes, and then we'll decide what to do. Yeah, this
You
is
can
pretty
also
much.
show that real to sim video if you have it on your
Uh,
desktop.
Desktop alella. Should is it which where did we send it?
WhatsApp. You want me to send it on Telegram?
Yeah, that would be better.
1 second.
Where is this?
The difference between gazebo and Arvis. So, Arvis is more used for what is actually happening in your real life scenarios. Okay, it's a visualization tool for all the data that's coming in from your sensors. Like, I will show you one, like Lingesh now will show you one Arvis example. Gazebo is more used for simulations, for more environments that you want to simulate in and see how it behaves without actually doing it.
And our wish is to get to know in real life what it is doing. Now, like we'll show you a laser scan only not I was sending.
Oh no, oh, you want me to send laser scan also?
Whatever you have, you send.
I
What
am
you are
sending
sending a
real.
Toda.
I'm sending real to sim. Yeah,
Okay, that also works.
I'll send the point cloud also. 1 second.
Please. If you find it, send.
I have it somewhere.
Anybody else have any other doubt in the meanwhile? See, if all this sounds like gibberish, it's completely alright. The first time my senior Sanket, okay, he was the guy who taught us, and when he was like, bro, the Arvis gazebo, that this blah blah blah. The first thing that came to my mind was like, bro, what the fuck are you talking about? I felt so what kind of insecure, like, oh, there is so much to learn and stuff. So it is completely all right if you feel intimidated. Intimidated is the right word. It's completely all right if you guys feel little intimidated. Once you'll get used to it, to be honest, and once you sit with it for 2 3 hours, no, then you'll be like, okay, I'm getting a little of the what Ross is trying to do. You'll get that feeling. Once that you get, I think you'll be able to work along.
Yeah,
Where am I?
it's coming down. Internet slow.
Nice. Guys, anybody, any other question? Or if you want to ask something in the chat, or unmuting would be preferable, or in the chat is also fine. Or at least tell no also. Any doubts?
One video sent. Sent.
Okay. Ignore the caption and all, okay? But yeah, I'll show the video.
Uh,
One sec.
Ignore the audio also.
Entire screen. Okay, no doubts. Nice. Okay. You guys can see now. Yeah, you can. Okay. See, this was real to sim, Noda.
Yeah, real to sim.
Yeah, this was real to sim. Now, when the bot is being moved front, you can see all. You will also be able to see in the RV screen that it is also moving. If the video is glitching, I think we can send the video also once.
I will send the video also.
Hmm. So,
This
hope you
took
can see
6 months to get working because we didn't have proper guidance.
now is the main character moment. This is see.
You can see those two axes, they move with respect to each other. So that's pretty much indicative of the robot actually moving. Now we move it back, it actually goes back towards the axis also.
Okay, this is one video of that. Whatever arrow mark you saw is known as transform. We'll get to that later. And this was visualizing laser data. Now, what that blue color thingy? Wait, this is okay. This blue color, whatever you're seeing, is basically what lidar, and the in the RVS window you can see whatever data it is getting. You can see in the RVS window. That is the laser scan which I showed in the this one also. So yeah, these are the two things which we have actually implemented, and you guys also will be able to, hopefully, if time permits. And yeah, that that's it. That's pretty much it, to be honest. Okay, one last what instruction maybe, that final Linux assignment will be sent tonight, 100% sure. I know. And second one is the installation guide. Make sure it is installed by tomorrow. And other tools for it also will send you, probably VS Code only. VS Code and ROS, some kind of, this one will do manual. We'll send it to you. Make sure you start off with the installation process. If majority of them get it installed, then we'll have a class tomorrow eveningish. And if you guys have, what about timings? You guys have any preference or what?
Also, I don't
I
mind
feel
doing
like,
like a small demonstration for the ROS2 installation. It doesn't take much time. So.
yeah, we'll send off a video also, like what exactly steps we'll be sending in the what manual. The same steps we'll
Yeah,
perform, and then you can follow it as well. Works, no?
works,
Okay,
okay,
nice.
fine. Yeah, also errors will come. Share it on the group. Find others who have the errors and work with them. Okay.
Okay. And another important thing, see now there is WhatsApp group for us, no? Like that. There is WhatsApp group, not WhatsApp group. There is this thing known as what is that now? Robotics. I think I forgot. Robotics Stack Exchange. Okay. This is where you ask all your questions regards to robotics. Like this, they've made it newly for from ROS2 they started. Before it was some what was it, bro? ROS.
There were different things, bro. Answers.ros.org and
Huh,
all that stuff.
those kind of things. Now they kind, it is like obviously what
It was very scattered before.
now
Now,
they are like properly there is some kind of direction, or there is a better platform for everything. If you have any kind of questions, any kind of doubts, even if we are not able to solve it, 100% someone on the internet would have done it for you. You can go check them out and get the job done. This robotic stack exchange is official what stack exchange of ROS. And the website I showed you, if you want, I can send you the links. Let me know if you guys want the link. That won't. That is not an issue. Is my screen should sharing?
no, it's not sharing.
Please. That's pretty much
When
it,
you get errors,
guys.
make sure to go
Huh.
to the stack exchanges first. Okay, don't go to ChatGPT or Bard and all. Not
No.
recommended because they haven't trained properly. The documentation is quite poor for ROS and all, and it has trained on poor documentation. Finding the solution takes longer when you use these AI tools. Get comfortable using Stack exchanges. Even with Linux, when you get Linux errors and all, get comfortable using the forums. Okay, it's an extremely great tool. Reddit, insanely good resource. Okay, don't need to tell. You put a question, you don't get an answer, put the question, space Reddit, you will get the answer. Okay, so
For sure.
use the forums, and if somehow you've gotten an error that has never ever come, post it on the forums, and someone will answer.
For sure. Okay, I think that's it, not from our side. Okay, guys, that's it from our side. If you guys have any questions or something, we'll take it up. Otherwise, you can leave the date. Tomorrow, I think it'll be like some 6:30 to 8